Hi everyone. Today in this lesson, we will be dealing with the electric potential energy. Electric potential energy. So let's see what is the definition of electric potential energy. There are many definitions are there. So let's see two definitions here. Amount of work done in assembling the charges at their locations by bringing them in from infinity. Okay, that means to bring the charges from infinity and assemble in somewhere. Okay, to for that how much work has to be done, or we can say that it is energy possessed by a system of charges by virtue of their positions. So now to understand this one, let's see one of the example, that is a potential energy of system of 2-point charges. System of 2-point charges. Imagine a position P1 somewhere. You are bringing a charge Q1 from infinity. Q1 from infinity to the position P1. To find the position vector, we will take a common origin. Say it as this is the common origin O. So O to P1, you take it as R1. If you are writing in a vector notation, you can note it down R1 vector. So I am not marking it as R1 vector because you already know this one as a position vector. Now you are bringing which charge from infinity? The charge Q1. How much work has to be done? How much work has to be done? Say it as W1 is the work done to bring the charge Q1 from infinity to the position P1. We can say that there is no need of any work to bring this charge from infinity. Why? At the position P1, there is no external electric field. So no need of any work is required, and there is no potential also. So what is W1? 0. Now you just think about, you are bringing another charge to the position P2. And you are bringing another charge Q2 to the position P2. Is there any work required? Yes, of course. Why? At position P2, there is a potential, or we can say that there is an electric field due to the Q1 charge. If so, I'm writing here, what is the potential at the position P2 due to Q1 charge? Say it as V1. So we can write the formula as V1 is equal to 1 by 4 pi epsilon 0. Potential due to which charge? Q1, right? So Q1 divided by the distance between P1 and P2. If you see this one, position vector, if you are drawing O to P2, if you take this O to P2, you take it as R2. If so, what is the distance between P1 and P2? If you are using vector notation, you can write the R12. We are not taking here the vector notation, so you write the equation R12. So V1 is equal to 1 by 4 pi epsilon 0 Q1 divided by R12. Now the next question is therefore what is the total work done? What is the total work done to bring the charge Q2 from infinity to the position P2? So I can write it as W2. So which charge you are bringing? Q2. Which potential is present at the position P2? That is the V1. So write the formula here, W1 is equal to Q2 into, what is V1 now? 1 by 4 pi epsilon 0 Q1 divided by R12. So we got now, sorry, this is a W2. We got now W1 is 0 and here it is W2 is equal to this equation. If so, what is the net work done to keep this configuration like this? To keep these two charges like this with a distance R12, how much work has to be done? So you can write here the total work done is equal to W1 plus W2. If so, this total work is stored as potential energy. So in order to keep these two charges, the total work what we have done here, that is stored as potential energy, and that potential energy is called what? Electric potential energy. Now you can write the formula as U is equal to, add the two equations, so W1 is 0, so what is W2 now here? 1 by 4 pi epsilon 0 Q1 Q2 divided by R12. So this is the potential energy of system of 2-point charges. Okay, so as a note you can see here what will happen if the potential energy is positive. If the potential energy is positive, we can say that the force between the two charges will be repulsive. Force between the two charges will be repulsive. If the potential energy is negative, what is its meaning here? The force between two charges will be attractive. Clear? So this is talking about electrical or electric potential energy, and we have discussed now the system of 2-point charges. Now let's think about the system of 3-point charges. It's a part of potential energy. Just imagine a position P1. If you want to bring a charge Q1 from infinity to the position P1, so what you are bringing here? A point charge Q1 from infinity to the position P1. Is there any work required? No. There is no work is required. Why there is no work is required? Because there is no external electric field, or there is no potential is there. So I can write here work done to bring the charge from infinity to the position P1, say it as W1, which is equal to 0. So write it as the first one, W1 equal to 0. Now you think about another position P2. Another position P2. Now which one you are bringing here? Which charge you are bringing? Say it as a point charge Q2 you are bringing. If you want to bring a charge Q2 from infinity, is there any work required? Yes, work is required. Why? Now at position P2, there is an electric field due to Q1. Or we can say that the potential is present at P2. In order to write the potential, just think about the distance between P1 and P2, say it as R12. That is, we are using the vector analysis. That you already learned that one. Say it as R12. If so, what is the potential? You can write the what is the potential at position P2 due to Q1? Say it as V1. Potential at P2 due to Q1. V1 is equal to 1 by 4 pi epsilon 0 Q1 divided by R12. Now which charge you are bringing now? Q2. So how much work has to be done? I can write here W2. To bring the charge Q2, W2 is equal to, the bringing charge is Q2. Now at the position P2, which potential is there? That is V1. So what is the W2 formula here? W2 is equal to Q2 into V1 is 1 by 4 pi epsilon 0 Q1 divided by R12. So now what is the W2 here? W2 is equal to 1 by 4 pi epsilon 0 Q1 Q2 divided by R12. Equation number 2. Now this is the one we have already learned just now. Now just think about another position P3. Now you want to bring another charge Q3 from infinity. Is the work is required? Yes, work has to be done. Why? Now at position P3, there is two potentials are there. Which are the two potential? One is due to charge Q1 and another one is due to charge Q2. So there are two potential at P3. So definitely work has to be done. So let's think about you're bringing Q3 and the distance between P2 and P3 is taken as R23 and distance between P1 and P3 is taken as R13. Clear? If so, we can write the W. Before that, what at the position P3? At position P3, what is the total potential? So I can write here V1 due to Q1. Formula 1 by 4 pi epsilon 0 Q1 divided by, what is the distance here in between P1 and P3? That is R13. And what is the potential due to Q2? You write it as V2. What is V2 here? 1 by 4 pi epsilon 0 Q2 divided by R23. Now we are going to write here, therefore, the total work done. Total work done. So W3 is equal to W3 is equal to which charge you are bringing now? Q3. So I can write here Q3 into what is the potential due to charge Q1, that is equal to V1 plus Q3 into what is the potential due to Q2, that is V2. So what is the formula here? W3, that is a work done to bring the charge Q3 in the presence of Q1 and Q2, that is equal to, what is the formula become? Q3 into, what is the V1? 1 by 4 pi epsilon 0 Q1 divided by R13 plus Q3 into 1 by 4 pi epsilon 0 Q2 divided by, what is the distance between P2 and P3? Taken as R23. So this is the W3. Now all these systems are configured, it is placed in as a system. If so, what is the total potential energy? W is equal to W1 plus W2 plus W3. So W is equal to W1 0, W2, what is W2? We have written here equation number 2, 1 by 4 pi epsilon 0 Q1 Q2 divided by R12 plus, now what is W3? 1 by 4 pi epsilon 0 Q1 Q3 divided by R13 plus 1 by 4 pi epsilon 0 Q2 Q3 divided by R23. This net work done to configure these three charges as a system is stored as potential energy U. So what is the net formula here? 1 by 4 pi epsilon 0 is common now here, can be taken outside. Q1 Q2 divided by R12 plus Q1 Q3 divided by R13 plus Q2 Q3 divided by R23. So this is the net work done or the total potential energy stored in these three charges. Clear? Hope you understand this one. Thank you.